Good evening everyone, good evening. I welcome you all again to NEET Elite. I hope you guys are doing great, having a good time. So people, before starting the session, you guys can let me know in the chats. You guys can give me the green signal from the chat box so that I'll get to know that I'm audible and visible to you, right? Hello Fazan, hello Ubad, hi Inabat, hello Anthony, hi Dakshin, hi Bibek, hello Saja, hi Anil, hello Sahil, hello The Way, hello Yuvashri. Welcome back everyone, welcome back. Hello Dr. Iqbal. Hello Sahil, walaikum salam. Which one is the next chapter? See, first of all, this chapter is not completed yet. This chapter will take 3 more sessions apart from this session, okay? And after that, most probably, I'll be starting the general organic chemistry for you, GOC, right? Because majority of the students have, they want exactly GOC to get started. So most probably I'll be starting GOC after this chemical bonding chapter on this channel, right? So just let me know in the chats if you guys are, if I'm audible and visible to everyone, right people? Yes? Okay. Arvind, P block will be also done. P block will be also done. Everything I'll be trying to finish out on this channel itself, yes. Yes, GOC comes under organic chemistry only, right? Okay. So people, as you all must be knowing, tonight we are going to have the Menti session, right? Till now, we have covered the majority portion of this chapter, chemical bonding, right? So whatever concepts we have discussed till now, right? Let's have a Menti on the concepts which we have discussed till now on this NEET Elite channel, right? So before starting the session, the ones who have just joined in, who are new to the channel, let me introduce myself. Well people, my name is Wassim and I'm your chemistry master teacher right here on this NEET Elite channel, right? The ones who have not liked the video yet, please do like the video, share the video with friends, do subscribe to the channel and do not forget to hit the bell icon as well, right? So do like the video, share the video and subscribe to the channel as well, right? Okay. So, well, in order to participate in the tonight's Menti session, right? In order to participate in the tonight's Menti quiz, I would want you guys to go to www.menti.com and there you need to use the code 823848226. Then only you can participate in the tonight's Menti session, right? I want you guys to join in fast. Yes, Sajja, exactly. Join in fast people, go to www.menti.com and there you have to type the code 823848226. Then only you can participate in the tonight's Menti session. Otherwise, you won't be able to participate, right? So I want you guys to go to menti.com fast and there you need to use the code 823848226. Then only you can participate in the tonight's Menti session, right? That's wonderful, Chitra. You have joined already. Okay, Trimanjot has already joined in. Ashwarya has joined in, right? I want every one of you to join in as soon as possible, yes? Yes, Prashad, after this chapter we'll be starting GOC, yes. I want you guys to join in fast people, yes. Join in fast. Well, Vinay has joined in, Ubad has joined in, Prashad has joined in, wonderful, Fazan has already joined in. Yes, Facts Unknown is in. Sushmita Sarkar has joined in. Yuvashri has also joined in, wonderful. Yes, Sajja, you can watch those as well. Absolutely. No, this is not the last lecture of chemical bonding. There are some 3 more sessions left, yeah? Thank you, Ayush. Thank you so much. So people, again, I'm telling you, the ones who have just joined in, if you want to participate in the tonight's Menti session from the chapter chemical bonding, I want you guys to go to www.menti.com and there you need to use the code 823848226. Then only you can participate. Otherwise, you won't be able to participate. And let me tell you, you guys are not supposed to write the answers in the chat box. Whosoever among you is going to write the answers in the chat box, he or she is going to get blocked at that time itself by our operational team, right? Yes. So make sure you don't answer in the chat box, right? If you want to answer, if you want to participate in the Menti session, go to www.menti.com, type the code, right? Then have fun, participate in the session, right? Yes? Perfecto. Well, I can see a lot of people have already joined in. So, Let's get going then. Let's get going then. Let's get going then. Yes. All right, let me see exactly how many people have joined in. Well, I can see a lot of people have joined in. By the way, I liked this one. This one is nice, yeah? Yes? Okay. Perfect, guys. So, let's start the countdown. You need to look at your screen, and this is the first question which is on your screen. A very simple and basic question, right? This is going to be the level 1. Level 1, these are going to be the level 1 questions from the chapter chemical bonding, very simpler ones. The attractive force which holds various constituent atoms or ions, etc. together in a chemical species is called as what? Do we call it as chemical bond? Do we call it as chemical compound, ionic compound, covalent compound? You have got 5 more seconds left. A very simpler question, right? We have started the chapter from this definition itself. I hope you remember, right? The time is up. And majority of the students have given the correct answer. Absolutely, you all are perfectly right. Yes, that attractive force which holds the ions or atoms together in a chemical species is something which we call as chemical bond, right? Very simple and basic one. Yes? Okay, so let's move on to one more question then, right? I'll start the countdown. You need to look at your screen. And people, you have got just 25 seconds to solve this one. The bond formed as a result of electrostatic attraction between the positive and the negative ions is called as, what do we call this bond as? What do we call this bond as? The electrostatic force of attraction between the cation and the anion, right? What do we call this bond as? You have got some 10 more seconds left. I want you guys to do it fast. Yes? Absolutely. Vishnu, no need to answer in the chat box, bro. If you want to participate, go to menti.com. Right? Then participate. Otherwise, don't write the answers. You can consider it as a request or a warning. Yes? Or else you are going to get blocked. So, majority of the students have given the correct answer. Absolutely. In electrovalent bond. What is electrovalent bond basically? Electrovalent bond is formed by the complete transfer of electrons. And due to complete transfer of electrons, cations and anions get formed. And there will be electrostatic force of attraction between those cations and anions, and that electrostatic force of attraction is something which we call as ionic bond or electrovalent bond. As simple as that. Yes? Right? Ayush Redox, we have already completed. You can check it in the playlist. And the ones who have just joined in, do not forget to like the video, share the video, and subscribe to the channel as well. So I'm starting the countdown. Look at your screen, people. Look at the third question. Right? Have a look. Which of the following compounds does not follow the octet rule for the electron distribution, right? You are given with PCl5, you are given with PCl3, H2O and PH3. Among all, which of the following is not going to follow the octet rule? Yes? Shweta is asking, sir, how can I get your lecture notes? Well, I keep on sending the notes in the Telegram group. You need to join the Telegram group so that you can get the notes as well. Okay? Surely, Fazan, I'll give you some time to write the name. So the time is up. Well, again, majority of the students have killed this question, right? PCl5, in PCl5, I mean, it does not follow the octet rule. Why is that? Because if you look at PCl5, it is forming 5 sigma bonds. That means there are 10 electrons in its there are 10 electrons basically present in the outermost shell of PCl5, right? Which is not as per octet rule. Yes? Okay? So it was again a simpler question. I'm sure it's clear. Moving on to one more. I'm starting the countdown in 3, 2, 1, and now. Look at your screen, people. Okay. Among the following, which compound will show the highest lattice energy? Okay. This question I'm giving you some time, some 35 seconds. And I'm sure you guys are going to kill it. Yeah? Yes, I use leaderboard. I'll be showing after every 5 questions or 4 questions like that. Give it a try. Which of the following compounds will show the highest lattice energy? KF, NAF, CSF, RBF. Again, I'm telling you, don't write the answers in the chat box. Vedantu NEET Elite English. If anyone is writing the answers in the chat box, please do block him or her at that point of time itself, right? Do that. Well, I can see again majority of the students have given the correct answer. Yes, people, have a look exactly. We were given with something as KF. KF one compound given to me. Then I was given with NaF. Then I was given with cesium fluoride, CSF. Then RBF, right? Sorry, RBF, correct? If you remember, I have discussed lattice energy with you. Lattice energy is directly proportional to charge and inversely proportional to size, correct? This is something which I have discussed with you, correct? Now people have a look. Over here the cation is K positive, this F negative, this Na positive, F negative, CS positive, F negative, Rb positive, F negative, right? Over here, anion everywhere is same. So I'm not going to decide on the basis of anion. I'm not going to decide on the basis of anion, as simple as that, right? And again, the charge present on the cation everywhere is same. Yes, the charge present on cation everywhere is same. So I'm not going to decide on the basis of charge as well. I'm going to decide on the basis of size of the cation. Wherever cation has got the lesser size, there only lattice energy will be the maximum, right? Now, among Na positive, K positive, Rb positive, CS positive, right? On moving from top to bottom, what happens to ionic size? Ionic size increases on moving from to bottom, right? So this Na positive, it has got minimum ionic size. If it has got minimum ionic size, lattice energy in case of NaF will be maximum. That's why this NaF will be your answer, right? We have discussed this in detail, right? The ones who have just joined in, do not forget to like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Well, people, I'm giving you some time to put down your names, right? Okay? Because people are requesting to give some time to write the names or something. I'm giving you some time. Yeah? Right? Do it fast, do it fast. Do it fast. Name it fast. Okay, I think this much of time is enough. Yes, Mickey, I've given you some 5 seconds to write the names. Right? Okay, let's move on then. Let's move on, people. Let's move on. Let's look at the 5th question. Then after this, I'll be showing you the leaderboard, right? Okay, which of the following bonds will have highest ionic character? Which of the following bonds will have highest ionic character? Highest ionic character. Which of the following bonds will have the highest ionic character? I want you guys to do it fast. Hi, HF, HCl, HBr. Give it a try. 15 more seconds you have. Yes, 15 more seconds you have. And I'm sure you can kill it. Rizwan, no need to answer in the chats, bro. How many times I'll tell you? Vedantu NEET, Elite English, please block these guys. Rizwan and Shweta Garg. Please do that. Okay, majority of the students have given the correct answer again. HF, in case of HF bond, the ionic character will be maximum. Why is that? Because of the highest electronegativity difference between the two atoms, right? Okay, there is highest electronegativity difference between hydrogen and fluorine in case of HF, right? Due to which its percentage ionic character will be maximum in case of this HF, right? Yes, I'm sure it's clear to everyone. So let's have a look on the leaderboard. Let me see if the leaderboard comes now. Yes, let's have a look on the leaderboard, people. All right, we have got Dakshin Kumar, the fastest one to answer this one. Then we have got Harita, we have got Charan, we have got Ambril, we have got Ashley, Homer, Sushmama, Hafsa, Tom, and Ragul. Wonderful, guys. Good job done, right? And Dakshin is the fastest one to answer this question. Wonderful. Okay, moving on to one more then. This is going to be the 6th question. I'll start the countdown. I want you guys to do this fast. The molecule which has zero dipole moment. Which of the following molecule will have zero dipole moment? Dipole moment is something which we have discussed in detail, I hope, right? I hope you remember that. Yes. Which of the following molecules will have zero dipole moment? Kill it. It's a very simpler one, right? It's a very, very simpler one. 3, 2, 1. The time is up. And I can see again maximum students have got the correct answer. Absolutely, people. BF3 is the molecule which is going to have the net dipole moment as 0, right? Okay, because of its symmetry basically, right? In case of BF3, the structure is trigonal planar, the bond angle is 120, right? Due to its trigonal planar structure, yes, the net dipole moment of the molecule is going to be 0, right? Let me show it to you first of all. How come? See, for example, if I talk about BF3, this is B, this is F, this is one more F, this is one more F, correct? Okay. If you talk about this BF bond, I'll say fluorine is more electronegative, due to which fluorine will get delta negative charge and boron will get delta positive charge, right? So over here I'm getting a dipole whose moment is going to be from positive to negative. Similarly, positive to negative. Similarly, positive to negative, like this, correct? If I talk about these two dipoles, this one and this one, right? If I talk about these two dipole moments, right? What is the resultant of these two dipole moments? Resultant of these two dipole moments will be in this direction, and this resultant of these two dipole moments will cancel out exactly this one. That is why the net dipole moment of this molecule comes out to be 0, right? Yes, due to the symmetry. Perfect. I'm sure it's clear to everyone. I'm moving on to one more then. Look at your screen, look at your screen. I'll start the countdown. Okay. Which of the following possesses the dipole moment? Which of the following possesses the dipole moment? Yes, which of the following possesses the dipole moment? Give it a try fast. Give it a try fast. And the ones who have just joined it, if you want to participate in the Menti session, go to menti.com, type the code, then participate. And the ones who have not liked the video, do like the video, share the video with friends, and do not forget to subscribe to the channel as well. Yes. 20 more seconds here, people. 20 more seconds, 15 more seconds. It's a simple equation, right? 10 more seconds, kill it. Okay, 5 more seconds. The question was, which of the following possesses the dipole moment? And majority of the students have given the correct answer, right? See, if you talk about CO2, this is the structure of CO2 as you all must be knowing, right? This will be negative, this will be positive, so the dipole moment direction is in this way. Similarly, positive, negative dipole moment direction in this way, right? This cancels this, so net dipole moment of this molecule is 0, as you all must be knowing, correct? We have got parachlorobenzene. In case of parachlorobenzene, again I'll be having what? The net dipole moment 0, correct? If you talk about this molecule, this is chlorine. At the para position, we have got chlorine, right? So this chlorine is electron withdrawing. Yes, due to which it gets negative and this carbon gets positive. So dipole moment direction is in this way. This chlorine is again electron withdrawing. So negative, positive, dipole moment direction in this way, right? So this dipole moment gets cancelled out. So the net dipole moment of this molecule is also 0. Yes. If you talk about CH4, due to its symmetrical distribution, right? Due to its symmetrical structure, its net dipole moment is also 0. There comes NH3. In case of NH3, the net dipole moment is going to be non-zero, right? This is N, this is hydrogen, this is one more hydrogen, this is one more hydrogen, there's a lone pair on this nitrogen as well. Among nitrogen and hydrogen, nitrogen is more electronegative, so negative charge on nitrogen, positive charge on this hydrogen. So the dipole moment direction due to this bond is in this way. Due to this bond, it's going to be in this way. Due to this bond, it's going to be in this way. And due to the lone pair, it's going to be in this way, right? So the net dipole moment of the molecule is going to be upwards. Net dipole moment of the molecule is going to be upwards, which is non-zero. So, right, NH3 is the molecule which possesses the dipole moment. This is something which we have discussed in detail, if you remember, right? We have discussed all this in the dipole moment. Perfectly. Moving on. Moving on to one more, right? Okay, I'll start the countdown. You need to look at your screen, people. I want you guys to look at the screen. Okay, which of the following possesses the dipole moment? Which of the following possesses the dipole moment? SO2, H2S, SF4, SF6. Okay. Right? 30 more seconds you have. You can solve this. We have discussed. We have discussed dipole moment in detail, right? तुक्के नहीं मारना है. You have to solve it. Give it a try fast. Well, majority of the students again have given the correct answer. It is going to be only the SF6 which is going to have the net dipole moment 0, right? Due to the symmetry present in SF6, it has got the perfectly octahedral structure, and due to the symmetry present in SF6, the net dipole moment is going to be 0. In all the other cases, you will be having the dipole moment, right? You can check it out afterwards, right? SO2 bent structure it will be having. Similarly, H2S, it has got the angular structure, yes, like water. It will be having the net dipole moment. SF4 seesaw structure, it will be having the net dipole moment. This is the only one, SF6, which has got the perfectly octahedron, perfectly symmetric structure, which cancels out all the dipole moments and makes its net dipole moment 0, right? As simple as that. Perfect. I'm moving on to one more question, people. I'm starting the countdown. You need to look at the screen. You need to look at the screen. Okay. According to VSEPR theory, the geometry of the covalent molecules depends on, right? This is something which I've discussed yesterday only, guys, and I'm sure you can solve it easily now. This is something which we have discussed yesterday only. As per your valence shell electron pair repulsion theory, the geometry of the covalent molecules, it depends on what? Geometry of the covalent molecule depends on what? This is something which we have discussed in the last session only, yesterday. I'm sure you can solve it. It's okay, Nitya. Now join in fast. Exactly, it's a chocolate question, right? 3, 2, 1, the time is up. Let me exactly see how you all done it. Well, absolutely, you guys are perfectly correct. You guys are perfectly correct. All the above is going to be the correct answer. The geometry, as per VSCPR, the geometry of the covalent molecule, it depends on the number of bond pairs. It depends on the number of bond pairs. The number of lone pairs, absolutely. The number of lone pairs present in the outer shell of the central atom, correct. All the above, absolutely. All these basically factors, they decide the geometry of a covalent compound, right? That's something which is discussed. In the last session only, we saw exactly the shapes and geometries of different molecules as per VSCPR, right? Okay. And as per VSCPR, there will be basically repulsions between the valence shell electron pairs, which involves bonding as well as non-bonding electron pairs, right? And molecule tries to acquire that shape in which the repulsions are minimum and stability is maximum. That's something which is discussed. Yes. So let's have a look on the leaderboard. But before that, we have got one more question to solve. This is the question. Look at your screen. Predict the correct order of electron repulsion. Predict the correct order of electron repulsion. This is something which you can kill, right? And this question was once asked in NEET examination as well, people, right? Can you believe that? I think in 2018 or something, or 19, this question was asked. Predict the correct order of the electron repulsion. Simpler one, right? 10 more seconds you have. Yes, Sanjeevan, I'm in Srinagar, Jammu and Kashmir, yes. Well, I can see majority of the students have given the correct answer. It's absolutely going to be lone pair repulsions are always greater than lone pair bond pair, which are again greater than bond pair repulsions. That's something which you have discussed yesterday only in VSCPR theory. I hope you remember that. Yes, if you have not watched the VSCPR theory yet, please go and watch that. That is one of the most important theories of this chapter from which question frequently comes. Yeah. Even the next theory which I'm going to discuss, maybe day after tomorrow, that's going to be molecular orbital theory. That's again one of the most important theories, right? From which question frequently comes. Anyways, let's have a look on the leaderboard. Okay, we have got Rakesh, the fastest one to answer this question, right? And topping the leaderboard as well. Then we have got Afia, we have got HK, Prachi, Ashutosh, Charan, Alna, Vishu, Dakshin, and Aishu, Wassim sir student. Wonderful, guys. Good job done. Moving on to one more question. Yes. Perfect. Look at the screen, guys. I've started the countdown. The shape of ClO3 negative ion, according to VSCPR3. The shape of ClO3 negative ion as per VSCPR will be. What do you think is the answer of this question? Give it a try. You have got some 25 more seconds to solve this one, guys. Yes? 25 more seconds. Give it a try fast. Umar Bashir, do not write the answer in the chats. This is a Menti going on, bro. I hope you know what Menti is. Right? Vedantu NEET Elite English channel. Vedantu NEET Elite English. You can block all these people who are writing the answers in the chats. Just block all these people right now. So, if we talk about ClO3 negative, have a look on this, guys. This is ClO3 negative, correct? First of all, this chlorine is the central atom over here, And how many valence electrons are there with chlorine? 7, and there is a negative charge, so 7 plus 1 comes out to be 8, right? So chlorine, it's forming bonds with oxygen like this, right? This is the rough structure of chlorine which I've made. So out of 8 valence electrons of chlorine, it is using 1, 2, 3, 4, 5, 6, right? Out of 8 valence electrons, it is using 6 valence electrons to form bonds. Out of 8, it is using 6. So there'll be 2 electrons left as such on chlorine in the form of a lone pair, right? How many sigma bonds do we have? We have got 1, 2, and 3. 3 sigma bonds. How many lone pairs are there with the central atom? 1 lone pair, right? 3 sigma, 1 lone pair. What is going to be the shape? What is going to be the type of the molecule? Type of the molecule is going to be AB3L1, right? AB3L1, and in AB3L1, what is the steric number? Steric number is 3 plus 1, 4. Hybridization is sp3. Geometry is tetrahedral, but the shape will be absolutely pyramidal, right? Same as that of NH3. I'm sure it's clear to everyone. Yes, this is something which we have discussed. How do we calculate all these factors, right? How do we check the shape, geometry, every single thing which we have discussed till now, yeah? Right? Okay, moving on to one more question, people. Moving on to one more question. I'll start the countdown. You need to look at the screen. What is the correct increasing order of lone pair of electrons on the central atom, right? Correct increasing order of lone pair of electrons on the central atom. Give it a try. Let me know its answer. Give it a try fast. Give it a try fast. Give it a try fast, guys. Whosoever whosoever wrote the answer in the chats, trust me, you're going to get blocked now. I'm just typing, I'm just talking to my operational team guy only. Yes? Now you won't be able to answer the questions. You won't be able to chat itself, right? Anyways, majority of the students have given the correct answer. Let's have a look. Let's have a look. Okay, we have got IF7, we have got IF5, we have got ClF3, we have got XCF2, right? Let's check one by one. If I talk about IF7, correct? Iodine has got 7 valence electrons, and out of 7, it has used all these 7 valence electrons to form the 7 sigma bonds. So there'll be no lone pair on this iodine, correct? If you talk about IF5, in case of IF5, iodine will be having 1 lone pair because it has got 7 valence electrons, and out of 7 it is using 5. So 1 lone pair on this iodine. Similarly, if you talk about ClF3, chlorine has got some 7 valence electrons. Out of 7 it is using 3. So there will be 4 electrons left as such on chlorine. That means 2 lone pairs on chlorine. 2 lone pairs, correct? Then we have got XCF2. If I talk about XCF2, there are 8 valence electrons with the central atom. Out of 8, it is using 2. So there'll be 6 electrons left as such on xenon in the form of lone pairs. So there are 3 lone pairs on xenon. Now you can arrange them on the basis of increasing or decreasing order, whatever is asked, right? You can kill the equation. So finally, you get this as a result. Yeah? Okay? I'm sure it's clear to everyone. I'm moving on to one more question, people. I'm moving on to one more question, right? Okay, I have started the countdown. The number of lone pair and bond pair of electrons on sulfur atom in sulfur dioxide molecule are respectively. What do you think about this one? What do you think about this one? Give it a try fast. Give it a try fast, people. The number of lone pairs and bond pair of electrons on the sulfur atom in sulfur dioxide molecule are respectively. Give it a try. You have got some 5 more seconds to solve this one. Yes. The time is up. Well, not majority of the students have got the correct answer in this one, right? So you got confused in this, I believe. So the number of lone pairs and bond pair of electrons on the sulfur atom in sulfur dioxide. If you talk about the sulfur dioxide, guys. If you talk about sulfur dioxide, correct? This is the structure of sulfur dioxide. Yes. So first of all, how many bond pairs are being formed? 1, 2, 3, 4. So there are 4 bond pairs, correct? There are 4 bond pairs. Point number 1. How many lone pairs are there with sulfur? In case of sulfur, there are some 6 valence electrons, and out of 6, it is using 1, 2, 3, and 4. Out of 6 valence electrons, it is using 4 valence electrons to form 4 bonds. So there'll be 2 electrons left as such on sulfur in the form of a lone pair. So there is 1 lone pair, correct? So in case of SO2, there is 1 lone pair and 4 bond pairs. So this is going to be the correct answer of this question, right? Okay. Let's move on directly to one more question. I'm going to start the countdown in 3. Okay. Before having a look on the next question, let's have a look on the leaderboard. Let's see who's topping the leaderboard now. Well, we have got Rakesh, the fastest. No, Rakesh is not the fastest one. Anyways, Rakesh is topping the leaderboard. Then we have got Dakshin, the fastest one. Ishpreet comes in. Prachi, Charan, Sakundala, Afia, HK, Ragul, Ashutosh. Wonderful, guys. Good job done. Moving on to one more then. Ayush, those are sigma bonds, basically, what you are talking about. In the question, it was asked that the total bond pairs. Okay, moving on to one more question. I've started the countdown, people. Have a look. Have a look. Using VSEPR theory, predict the species which has square pyramidal geometry. Square pyramidal geometry means 4 sigma bonds, 1 lone pair, right? Check it out. Check it out. Fast. Which of the following molecule will have the square pyramidal geometry? I mean, square pyramidal shape, right? Walaikum Assalam, Fatima, thank you. Give it a try fast, guys. It's a simpler one, right? We have discussed all this in detail. I hope you remember. So you have got some 3 more seconds. 3, 2, 1. The time is up. Yes. Let's have a look on the answer. So majority of the students gave the correct answer. Wonderful. If you look at BRF5, people, in case of BRF5, there are 5 sigma bonds and there is 1 lone pair on bromine. Correct? So its structure will be like this. This is Br. This is 1 of the fluorine. This is 1 more fluorine. This is 1 more fluorine and this is 1 more fluorine. All these 4 fluorine atoms with bromine, they are present on the same plane, and there will be 1 fluorine perpendicular to the plane like this, and there will be a lone pair on this bromine as well. So ignore the lone pair, then see the shape. It is going to be square pyramidal, right? It's going to be a square pyramidal shape like this, correct? So BRF5 is the one which will be having the square pyramidal shape, and I've discussed this example in the last session also, right? When I taught you the VSEPR, correct? Yes? Perfecto. Moving on to one more then. Moving on to one more. This is the 70th question, right? I'll start the countdown. Look at the screen. Look at the screen, people. In the structure of ClF3, the number of lone pair of electrons on the central atom of chlorine. Okay, ClF3. ClF3, people. Simpler one, correct? In the structure of ClF3, the number of lone pair of electrons on central atom chlorine will be. What do you think about this one? Simple question, right? The time is up. Well, again, majority of the students have given the correct answer. Absolutely correct, guys. If you talk about ClF3, right? If you talk about ClF3, how many sigma bonds are being formed? 3. How many valence electrons chlorine has? 7. Out of 7, it is using 3. So there will be 4 electrons left on chlorine as such, which have not participated in the bonding. That means 2 lone pairs, right? Okay, as simple as that, right? So basically there are 2 lone pairs on chlorine in case of ClF3. Yes? Perfect. Let's move on to one more then. Let's move on to one more. Okay, I'll start with the countdown. You can look at your screen. Look here, you can look at your screen, people. Total number of lone pair of electrons in I3 negative. This question was asked many a times in different examinations, right? Give it a try. Give it a try, people. Total number of lone pair of electrons. He's asking total number of lone pairs, right? He's not asking about the lone pairs of central atom. He's asking about the total number of lone pairs. Three, two, one. The time is up. The correct answer is going to be 9, right? 9 is going to be the correct answer of this question. Why is that? Have a look. If you look at the structure of I3 negative, people, in the last session itself, I told you in case of I3 negative, I mean, you can write this I3 negative in the form of I2 negative as well, correct? You can write it in this way as well, okay? And if you calculate the valence electrons of this iodine, the central atom, it's going to be 7 plus 1, which comes out to be 8. How many sigma bonds are being formed? 2 sigma bonds are being formed. How many lone pairs will be there on this central iodine? There'll be 3 lone pairs, right? What is going to be the type of the molecule? It's going to be AB2L3, right? If it is AB2L3, what is the steric number? 3 plus 2, that comes out to be 5. If steric number is 5, the hybridization is going to be sp3d, right? Okay, now have a look exactly. The geometry indeed is going to be trigonal bipyramidal, but trigonal bipyramidal is not the shape of the molecule. Shape of the molecule is going to be linear, right? Something which we have discussed. This is iodine, right? At all the equatorial positions, you will see lone pairs, right? Over here, there is one more iodine. There is one more iodine over here, right? So this is the structure. This is the structure of I3 negative. Now, people, there are 3 lone pairs with this central atom. Similarly, this iodine will be having 3 lone pairs. Anyways, this iodine will be also having 3 lone pairs, right? So total, there are how many lone pair of electrons? There are total 9 lone pair of electrons. Total. 3 with the central atom, 3 with this one, 3 with this one. So total, there are 9 lone pair of electrons, right? Yes. Samir, I have discussed about the steric number. You can check it out in the last session, right? We have discussed in detail, right? Last session was about hybridization, in which I discussed about the steric number, hybridization, and everything. Okay, you can check it in the videos. Perfect. Let's move on then. Let's move on, guys. I'll start the countdown again. Look at your screen. The species having bond angle of 120 degree. Simpler one, right? A very simple question. ClF3, NClF3, BCl3, PH3. What about this one? Give it right now. $20 more seconds. $10 more seconds, y'all. Exactly, guys, you all are perfectly right. If I talk about BCl3, there are 3 sigma bonds which this boron is forming. There is no lone pair on boron. Steric number comes out to be 3. If steric number is 3, hybridization is sp2, and whenever hybridization is sp2, the bond angle is going to be 120, right? So it's going to be B, this is Cl, this is one more Cl, this is one more Cl, and we call this geometry, we call this shape as trigonal planar geometry, in which the bond angle is kept as 120, right? This is 120 degree. Yes? Perfect. Moving on then to one more. Okay, so look at the screen, people. Look at the screen. Shape of methane molecule. What kind of question this is? A chocolate one. Really a chocolate one, right? Shape of methane is. Let me know fast. What is the shape of methane? CH4. Three, two, one. Exactly, all of you are perfectly correct. So if you look at CH4 molecule, right, it's a very common thing. I don't know why few students have marked it wrong. Anyways, this carbon, it's forming 4 sigma bonds. There is no lone pair on this carbon, so steric number comes out to be 4. If steric number is 4, hybridization is sp3. If hybridization is sp3, geometry is tetrahedral. And since the central atom does not have any lone pair, so its shape is also tetrahedral, right? Its geometry as well as shape is tetrahedral, correct? A simpler one. Moving on to one more. I'll start the countdown. The molecule not having pi bond is, which of the following molecule is not going to have pi bond? Cl2, O2, N2, CO2. Simpler one, right? Kill it. Perfectly done, guys. So in case of Cl2, there is a single bond between chlorine and chlorine. In case of O2, there is a double bond between 2 oxygen atoms. In case of N2, triple bond between 2 nitrogen atoms. And carbon structure, carbon dioxide structure, you all must be knowing, right? Which I've shown you few minutes back only. Right. So starting the countdown for one more question. Look at the screen. The angular shape of ozone molecule consists of. The angular shape of ozone molecule consists of. Angular shape of ozone molecule consists of. In case of ozone, is there 1 sigma and 2 pi bonds? Are there 2 sigma 2 pi bonds? Is there 1 sigma 1 pi bond? Is there 2 sigma 1 pi bond? What is it? What is it going to be? Absolutely, all of you are perfectly correct. It is going to be 2 sigma bonds and 1 pi bond. It is O double bond O single bond O, right? Okay. Basically, the structure of ozone, that is something which I'll be showing you when I'll be teaching you the coordinate bond as well, right? There also, I need that. Anyways, I'm moving on to one more. Starting the countdown, look at the screen fast. Which of the following statements is not correct? He's saying which of the following statement is not correct? Double bond is shorter than a single bond. Sigma bond is weaker than a pi bond. Double bond is stronger than the single bond. Covalent bond is stronger than the hydrogen bond. What do you think about this one? A simpler one, right? A simpler question this is. So you have got some 15 more seconds to solve this one as well. Yeah, kill it fast. Well, majority of the students have given the correct answer. Sigma bond is weaker than a pi bond. Is it a correct statement? No way. Sigma bond is always stronger than the pi bond. And I've given the reasons as well in the valence bond theory, right? That's something which is discussed in last session, in which I discussed VBT on this channel itself, right? You can check it out there, the ones who did not see the sessions till now. Yes, so that you can answer these questions properly, okay? The last question, people, on your screen. The last question on the screen. The nature of hybridization ammonia molecule. Again, a simple question, right? Yes. Very, very, very simple question this was. This is, 15 more seconds you have. Exactly. Perfect, guys. Exactly. You all are perfectly right. In case of ammonia, as you all must be knowing, we have got some 3 sigma bonds and there is 1 lone pair on nitrogen, right? So 3 sigma, 1 lone pair, 3 plus 1 comes out to be 4. So steric number is 4. If steric number is 4, hybridization is sp3, right? That's something which is discussed, correct? Yes. So people, this was the last question of the session. Now we are going to see who is the winner of this tonight's Menti session, right? So let me show it to you. Let's see who is the winner of this Menti session. It's going to be Dakshin, I guess. Yeah. Exactly. Dakshin Kumar is the winner of the tonight's Menti session. Wonderful. Congratulations, Dakshin. You have done a good job. These were all the level 1 questions from the chapter chemical bonding. Now, day after tomorrow, we are going to have the molecular orbital theory session, right? And then I'll be taking a session in which I'll be discussing the previous year questions asked in your NEET from this chapter, right? And then I'll be taking one more Menti session from the same chapter, which is going to be the level 2 and level 3 questions, right? So I'm sure you would have enjoyed this session. Yes? Right? So people, the ones who have not liked the video, please do like the video, share the video with friends, and do not forget to subscribe to the channel as well, right? So this was all from my side in the tonight's session. I congratulate Dakshin again for doing good in this Menti session, right? So let's catch up tonight only at 10:30 on Vedantu JE English channel, in which I'll be discussing chemical equilibrium. So with this, I'm taking leave here. I'll see you guys soon. Till then, you take care. Bye-bye. God bless you all and love you all. Do let me know your ranks of this Menti session in the comment section, right? Do let me know what your rank exactly was and which chapter you want me to start the next. Do let me know about that as well. Take care, guys. Bye-bye. God bless you all.